Hey everybody, this is Mr. Chernsky, and this is Unit 4, Lesson 3, three-dimensional geometry of prisms and cylinders. So we're going to start with prisms, and we're going to specifically be talking about how we find the surface area and how do we find the volume of prisms and cylinders. So a prism is basically something like what we see here. It is essentially we have two congruent bases. You can actually see it better on this one here. If you notice, we got these two trapezoids that are opposite each other, but all the rest of the shape is made of polygons. So we got all these rectangles around the rest of it, and then we have two bases that are congruent and they're parallel to each other. So this first one here, this would actually be known as a triangular prism. And the two bases, let's see, would be oops, these triangles here. Trying to get it so a little smaller. There we go. Those two triangular prisms, or sorry, two triangular bases. A lot of common mistake students make with prisms is that they think that the bottom is always the base, and that's not true. Okay, this is not the rectangle at the bottom is not the base. It's these two triangles because they're equal, they're congruent, and they're facing each other. They're parallel. Okay, so that's why this is a triangular prism. Okay, the formula for a surface area, and by surface area I mean all the area of everything around it. So in other words, if I were to unwrap this, say, a little bit bigger. Okay. So if I was to unwrap this, like cut it open like we were breaking down a box, what essentially I'd have three rectangles. For the three rectangle faces, they would not all be the same shape. This bigger one, we'd have a pretty big one here, and then a smaller one, and then slightly like medium-sized one, and then we would have our two bases, triangular bases, on like so. So there would be our two bases. Okay. So if I wanted to find the area, the surface area, I could like find the area of every single one of these individually, and then add them all together. That'd be the long way around doing it. But we have a shortcut formula that works on every single prism, no matter what shape the base is. And essentially what it does is it calculates the area of the two bases, so that's that 2b, capital B being the area of one of our bases, and multiply it times 2 because there's two of them. And then we find the area, essentially, of this big rectangle, like if we add all three rectangles together. So we just kind of think of it as one big rectangle. And we do that by multiplying that length there, which is essentially the perimeter around one of our bases, because our three sides are going to wrap essentially around one of our bases. So that's why we'd look at the perimeter of one of our bases, and that gives us this bottom blue length. And then we multiply that, which is what this p value is. And if we multiply that times this height here, which would be this value, the distance between the bases, we would get the area of these lateral, what we call the lateral surface area, which is essentially the three rectangles wrapping around. Okay, and that's what this first part does. Okay. So that explains how the formula works. In practice, it's pretty simple. You find three things. You find the area of one base, you find the perimeter of one of those bases, and then you identify what the height is. So if we start with the area of the base, well, this is a triangle, it's a right triangle, so we're going to need the it's going to be 1/2 the base times the height, and I mean lowercase base, so the base of the triangle, which would be 1.5, times the height of the triangle, which is 2. So when we plug that in, that's going to be 1/2 times 1.5 times 2. And if I work that out, 2 times 1.5 is 3. Divided by half gives me 1.5. So that's my area of my base. So I've got this part done. For the perimeter of the base, well, I need to add all three of our lengths around our triangle, which we have. So that's going to be 2 plus 1.5 plus 2.5, which is going to be equal to 6. And then for our height, well, that's just the distance between our two bases, so this length right here represents our height, so our h is just 10. So then we put it all in our formula. So our surface area equals, I'm just going to keep it color coded, so we're going to do perimeter, which is 6, so we'll have 6 times our height, which is 10, plus 2 times the area of our base, which is 1.5. 6 times 10, 60, plus 2.15 times 1.5 is 3, so our answer is going to be 63 meters square, or square meters. All right. We could work out this next one. This is a this is a what we call a trapezoidal prism. So if I was working out surface area for this one, area of the base would be, well, the formula for area of trapezoid is 1/2 base 1 times, or plus base 2 times the height, so that's going to be 1/2 6 plus 12, and our height of our base is 4, so that'd be 18, and half that's 9, times 4 is 36. Okay, so we got area of our base. Our perimeter of our base, so we got to add all the sides all the way around. So that is going to be 12. And if we just look at where the sides are, there's 5, there's a 6, so it's going to be 12 plus 5 plus 6 plus 5. So that's going to be 18, 28. And then our height is going to be 10. So now we can plug that all into our formula for surface area. So for surface area, it equals, let's keep it in the same color, 6 times 10. Oh, why am I doing 6? I'm sorry, 28. Look at the old picture. Sorry. 28 times 10 plus 2 times the area of our base, which is 36. Alright, and then 28 times 10, that's going to be 280, plus 2 times 36, that's going to be 72, so mental math here. You can use a calculator, of course, to do all this work. That's going to be 352. That would be square centimeters. Okay. All right. This last one, this would be a rectangular prism. And I'm just going to draw the insides of it so we can kind of see the faces a little bit better. Okay. Now the thing about a rectangular prism, if you notice, any of the sides has a any of the faces has a parallel and congruent side across from it. So really with a rectangular prism, you get to choose where your bases are. It could be the top and the bottom, it could be the sides, it could be the front and the back, whichever one you want to make it. So I'm going to, for this one, make it the sides here. We'll call these two, the left and the right, the base. Alright, so there's our base. So I'll do the rest the same way. And I'll do I don't like that deep green there. There we go. So our area or base is just going to be 6 times 5, which is going to equal 30. And then the perimeter of our base, so that's all the way around. Recall we got there's a 5 here and another 6 here, so it's 5 plus 5 plus 6 plus 6 to get all the sides. So that's going to be 22. And then our height, the distance between those two sides, that's going to be 11. So now we got all the parts, we'll just plug it into our formula. Keeping our color code, so 22 times 11 plus 2 times 30. So 22 times 11, that's going to be, my mental math is running out, 242. And then 2 times 30 is 60, so add those together and we get 302 centimeters squared. Okay, and those are how we do surface area. Our volume formula is actually way simpler. It's just the area of the base times the height. And actually, we can run through these pretty quickly and find the volume because we already have the area of the base and we already have the height. So for the volume problem of the last one we just did, that's just going to be 30 times 11, which is 330. Not 30. 330. And our units for volume would be centimeters cubed or cubic centimeters. So 302 centimeters squared for the surface area, 330 centimeters cubed for the volume. For the trapezoidal prism, that's going to be, area of the base was 36 times our height was 10, so that's really easy. That's just going to be volume equal to 360 centimeters cubed. And lastly, for the first triangular prism, that's going to be 1.5 times our height of 10, which is ultimately going to equal to 15 meters cubed. So those are our volume and surface areas of our prism. So let's take a look at cylinders. So a cylinder, the surface area formula actually works very much like the prism formula. If we were to essentially unwrap this cylinder like we did with the prism, we would have a long rectangular for the lateral part, kind of like this part. So that would be unwrap into a rectangle. And then we would have basically two cylinders, or sorry, two circles, I should say. Two circles that we would have to find the area for. The top and the bottom. So on the top part, the area of a circle is pi r squared. So we'd have two of those pi r squared. So that's this part right here. So the 2 pi r squared gives us our top and our bottom surface areas. And then if we looked at 2 pi r, 2 pi r is the circumference, so that of a circle, so that would be all the way around, which would be the length of our rectangle. And then the h would represent the height of that, so that would be that part. So that's how we get the area of our lateral part. So that explains where both parts of our formula ultimately come from. So, but really in practice it's pretty simple. You only need the radius, which is 5, and the height, which is 10. And you just plug it into the formula, so that's going to be 2 times pi times 5 times 10 plus 2 times pi times 5 squared. Now, I find it's easier to keep things in terms of pi rather than multiply everything out, because once you multiply pi, it gets really messy and you have to round all the digits and stuff. So keep pi in until the very end. Plus, you get a nice exact answer to use. So I just start by multiplying the numbers together. So 5 times 10 gives me 50, times 2 gives me 100 pi in the first part. And then I'm going to add that to, well, 5 squared is 25, times 2 gives me, I have 50 pi here. So altogether I get 150 pi, which if I then use my calculator to estimate that, that gives me 471.2. And the units are centimeters squared for my surface area. Could do the same thing for the second one, the area. Well, first I need to find radius. Radius in this case is going to be 4 because they give us the diameter. Diameter is all the way across, so radius is half of that. The height is 12. So therefore our surface area, sorry about the fire truck, really laying on the horn. Okay, so surface area is going to be 2 times pi times 4 times 12 plus 2 times pi times 4 squared. So 4 times 12 is 48 times 2, that give me 96 pi here, plus 4 squared is 16 times 2 is going to give me 32 pi, which altogether is going to give me 128 pi. So which would be my exact answer, and then if I approximate that, plugging it in, gives me 402.1, and that would be inches, square inches. Okay. Our volume formula is even simpler. It's really just the area of our base, so pi r squared times the height. So you only need those two things. So it's really, it pretty much is the exact same formula. It's really just area of our base, which is what that is, times the height. So pretty much the exact same formula as our prism formula. We just substituted pi r squared for the area of our base. So for volume is going to equal pi 4 squared times 12, so that's going to be 16 times 12, which is 192 pi exactly. Oops, clean that up a little bit. Or approximately 603.2, and those would be inches cubed or cubic inches. And if we finish up with our last one, same thing, volume is going to equal pi times 5 squared times 10 5 squared is 25 times 10 is going to give us exactly 250 pi for our volume, which is approximately 785.4. And our units are cubic centimeters. Oops. Okay. And that's how we find surface area and volume of prisms and cylinders. Next week we will look at pyramids and cones.